Hi, it's time for another math easy solution. I'm here to discuss a follow-up video to my earlier video on basically multiplying by ones by each other. This simple method which I showed, which is pretty amazing. But now look at basically why that works. Just go over a proof of that. And before I get to that, I just want to give a shout out again to Colin Malone. He's the guy that let me know about this amazing method after he pointed out a simple way of solving the calculation in my earlier video. You can see this one here where I have 9 ones times it by another 9 ones equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1, etc. You can see that in the video link below. Basically, before I get to the proof, I just want to go a recap on this method from example 1 of my earlier video. You can also see this in the video link below. Basically, if we have 11 times it by 111, so once again, we're only dealing with ones right here. That's all I'm going to be doing in this video. So the simple method is basically we count the number of ones. In this case, there is 5. So there's 5 ones, and then subtract 1 from that number. This is the number of digits in our answer, so we subtract 1. This equals to 4. So the answer is going to have 4 digits, 1, 2, 3, 4. And then we count up until the number of digits of the smaller number is reached. The smaller number is this one right here. There's 2 digits. So we count up 1, 2. And then the next digit will basically be the highest number until it can be counted down to fit the number of digits from step 1 or 4 digits. So it will be the highest number. In this case, it's 2. So we can put a 2 and then put a 1. So we can count it back down to 1 right here. And then basically this is our answer. And you can plug this in a calculator, but that is the answer. And I'm not going to go over many more examples on this, but so make sure you watch this in the video links below on a lot of the examples I went over. So to prove why this method works, well, I'll look at this calculation. So yeah, I'll look at basically using just basic hand multiplication techniques for multiplying this one right here. We have 6 ones times it by 1. So when we have this, we're just going to get, well, this is just going to be this times it by every one of these digits. It's going to be 1, 1, 1, 1, 1, 1. So as you can see, there is 7 total digits right here, but then there is 6 digits right here, or 6 ones right here. So there's 6 ones and 6 digits. I just want to write that down, because this will come in handy in a bit. So now if we were to multiply with another digit, so this time we'll multiply it by, well, there's 6 ones times by 2 ones right here, or 11. So the first thing to do, this multiply by every one of them. We're going to get 1, 2, 3, 1, 2, 3, and then basically we add another 0 to multiply this one. So we put a 0 right here. You can see a proof of this in this multiplication by hand in the video link below. So basically now we multiply this by every single one. So we get 1, 1, 1, 1, 1, and then there's gonna be 6 ones right there. So when we add these up, we're gonna get 1, 2, 2, 2. So add these up. I'll just put a plus. So we get 2, 2, and then 1 right here. So there is right here there's 5 2. So initially we had 6 ones when we just had 1. So 5 ones, and then we have, well, 7 digits total right here. So 7 digits. So yeah, so there's 7 digits right here, but then when this one here, since we added another 1, we have basically 8 digits right here. So from this one, since the initial step we lose a digit, so there's 6 right here, then we add 1 here, so there's basically 6 plus 1 equals to 7. Yeah, basically just corrected there. So 6 plus 1 equals 7 on the next row. So we always add another row right here. And then if we do the same thing but for adding another 1, yeah, and in this case we have 6 ones multiplied by 3 ones. Again, we're going to get 1, 1, 1, 1, 1, 1. Then we add another 0 to multiply this one by everything. So 1, 1, 1, 1, 1, 1. And then again we add 2 zeros now. We get 1, 1, 1, 1, 1, and then 1 right here. So now there's going to be, well, there's 6 digits right here, 6, there's 7, there's 8. So we've always added 1 extra, and there's total right here is going to be 9 right here. So there's 9, and then there's going to be 8 digits, and our answer is going to have 8 digits. And it's going to be, well, 1, 2, 3, 3, 3, and then this is how many? This is 1 more right here. So 3. Yeah, so there's 4 3s right here. They add up, and there's going to be a 2, and then there's going to be a 1 right here. So I made a mistake here. This is 5 2s, not 5 1s. I don't know what I was thinking there. So basically there's 5 2s right there. So in this case now there is 4 3s. So you see the pattern. and now there's basically 8 digits right here. So it goes from 6, 7, 8. So it's always adding one higher, but we have one less than this one right here. So it's always one less than the total number of ones. So this is basically, we've proved that step 1 and 2 are correct right here. And as you can see from these numbers right here, so we keep adding up until we can count down. As you can see, here's 1, 2, 3, 3 all the way here. So if we were to look at 6 ones times by 4 ones, well, we just look at the pattern. This one there is 10 digits, so our answer is going to have basically 9 digits. So we have a 9, or 10 minus 1 equals 9. So then the answer is going to be, well, when we add these up, so just make the digits 2, 3, so there's going to be 9 right here. And see the pattern, we're going to have 3 4s. So 3 4s, because you can see there's 6 1s, 5 2s, 4 3s, 3 4s right here. So 3 4s, and then we count them up right again. So we go 1, 2, 3, 4, and as you see, these are the number of 2s right here. This is the number of digits. So when this is number of 1s here, this is number of digits is 1. And there's 3 right here, so the highest number is a 3. There's 4, highest number is a 4. So this is basically this part right here, so this step right here. And then we're going to get 3 4s, and then 3, 2, 1. And then we could even calculate this out. Yeah, and basically here I've skipped the steps here. So if you were to do this part right here, add them up, we get 1, 2, 3, 4, 4, 4, and then it goes back down to 3. So as you can see, the exact same way. Instead of having to do it like this, you could just easily write it out like that. And then so just one more example. If we have 6 ones times by 6 ones, again we just solve it exactly how the method is. There's 12 right here, minus 1, so we have an 11 right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and the highest number is a 6. So we just count it up. It's 1, 2, 3, 4, 5, 6, and then there's only going to be 1 6, because there's going to be 3 4s, 2 5s, and then 1 6. So we get 5, 4, 4, and 3, 2, 1 right here. So anyways, that's all for today. If you learned from this quick, well, it's not really a proof, but it's just a way of just showing why this method works, and it's pretty straightforward. It's basically you follow the pattern. Anyways, that's all for today. If you learned from this, and remember, you can also download these exact notes in the Dropbox link below. I also want to give once again shout out to Colin Malone for letting me know about this method. It's pretty amazing. Anyways, that's all for today, and hope you learned, and stay tuned for another Math Easy solution.